Yeah, so it is kind of geometry heavy a little bit, but I think we'll be okay. All right, so here's where we're at. I already kind of explained this way back when we first started the three-dimensional systems, but you want to imagine your y and your x-axis. If you look at how it's labeled right here, it's kind of pushed down and rotated. It's kind of like it's doing a cartwheel onto the floor, okay? And so now we have this z-axis that is that three-dimensional space. So the y and the x are still that same thing. So again, you want to imagine that you're kind of tilting your head. And so what we want to label is that this is the positive y-axis, kind of going, now you can think about it as it kind of looks like your old x-axis, but now that's going up, right? You can imagine that going up. And then this would be the positive x-axis coming towards you, would be the positive x-axis. So again, imagine that you kind of take your regular xy, kind of rotate it. That's what we're looking at now. And that z-axis is what's coming out of the page. It's going up and down. And so this up here would be my positive z-axis, okay? And so then that means the other ones are going to be our negatives. So that's something that maybe you would want to label each time at the beginning until you get used to what direction is the positive, what direction is the negative, okay? And so all we're doing here is we're going to write the coordinates of each point. So we're going to do a couple together, and then you'll finish the rest up for like your homework, okay, or as practice. So I will say you're going to be doing number 3, 4, and 5 on your own, and we're going to do 1 and 2 together that look like this. So they're all kind of jumbled together. I tried to split them up pretty well. So you maybe want to circle 3, 4, 5. You're going to try those on your own after I tell you how we do 1 and 2. Okay? So that's going to be how this is. So it is homework. I am going to take this for a grade, just a completion grade. But on the study guide, I also have some more questions like this. So this is just kind of a preview. Okay, so let's go ahead and look at this. So when I'm writing my points, we're looking at the x, the y, and the z axis. So here's this is the easiest in my opinion when you have this kind of box shape, but we'll find that there's another way you can look at these points that's a little bit more complicated. So what I want to do is, here's my point, and I like to look at my x-axis first. Well, it's not coming forwards. It's not coming towards me. It's going backwards. And so how many spaces am I going backwards? I'm going 1, 2, 3 spaces backwards, right? It's already kind of labeled for me that that's 3 spaces back, okay? So that x value would be -3, right? So that's easy to see. When you have the dotted lines and it makes the box for you, it's a little bit easier to see, all right? Then we want to do the y next. And so with the y-axis, well, okay, I'm going 1, 2, 3, 4 spaces, positive, right? Positive y. So we're going to say this will be, 4. And then the last ordered part of the order triple is my z. So that is moving up or down, kind of entering that three-dimensional space. So we're going up 1, 2, 3 spaces. So notice how I'm always looking at the axis, right? I'm not, because what sometimes people will do is they'll try to like connect this point over here. You can't do that because it's three-dimensional, which is why this box, this outline is kind of here saying, well, this point is floating at that 3 mark on the z-axis. Okay, so you always want to count by the axis, not by its actual like in space, because it's not going to add up very nicely. Okay, so we would say 3 there. So that's it. That's all you're doing. When you want to write the coordinates of each point, you're going to give me the ordered triple. Okay, so let's try that again. So with this one may be a little bit harder to see, but again, we're kind of looking at the box, and we start with the x-axis. So my x-axis here is this one. And so again, coming towards me would be positive. So we can see that this box, I'm going 1, 2 spaces towards me. That's kind of where that box is. That's where that point is at. So we're going to say 2, and then I can go to the y-axis now. So the y-axis, I'm going to go 1, 2 over as well. Right? Again, I'm kind of going to where that box outline is. That's what I'm looking at. Not where it's actually connecting. Again, some people like want to connect this down. Don't do that. It's in three-dimensional space. And then finally, the z-axis, so up 1, 2, 3 spaces will connect me to that box here for my z-axis. So 2, 2, 3 would be my ordered triple. All right? So I'll give you a quick hint on number 4, though, because if you notice, that one, you're going to have a 0 involved because you're not moving one of the directions, okay? So what this means is I have not moved up or down, right? I've moved along the y-axis here, right? I've moved along the x-axis here, but I have not moved it up or down. So you will have 0, right, as you're not going any direction. So it's the same thing with a regular ordered pair. If you're not moving a direction, a 0 goes there. So my hint here is you're not moving up or down. You're just staying there. And that's okay. You can have that. All right. So then let's go ahead and jump to the next type of problem where it's now the arrows versus the box. So these can get a little bit more difficult to read, okay? But often this is how you will see your points, okay? So we're going to do 6 and 7 together. So you will want to circle 8, 9, and 10 to finish on your own. Okay, so again, this is how you will see it really next year, because it's really annoying to draw out a box every time, right? So, and this is how we will also plot our points. So we want to get used to this type of work. Okay, so let's go ahead and look at number 6. We don't have the box anymore. We have our arrows. And so, again, we go in that order of X, comma, Y, comma, Z. If you follow that right order, you're not going to mess this up. If you go out of order, that's where it gets kind of confusing. So go first, look along the x-axis. What direction is that arrow pointing? Well, it's pointing backwards, right? We're going backwards 2 spaces. So we go 1, 2. So that's, again, to the negative. So we can say this is going to be -2, comma. Then I look at my y. And so this is where, again, sometimes people can get this a little bit messed up, because you may be tempted to connect this line straight down from this arrow and say, oh, well, it crosses at 2. It does not, because you have to keep it parallel with those marks. Notice how these little tick marks, they're not straight up and down. They're at an angle. So it may be helpful for you to kind of extend out those lines, right? And so this is just kind of getting used to the way this is written. It's not straight up and down, it's at an angle. So actually, this is only one movement to the, I guess you can kind of think of it as up, right, for the y-axis. One movement along the y-axis, okay? So again, do not just say, all right, it looks like it crosses here at 2, because your tick marks are not going up and down, they're going sideways. So you want to keep it parallel with that, all right? So we're going to say there's 1 there, and then finally, now we're looking at the z-axis, okay? So this one, you really can, because look at how these z-axis lines are. You really can line it straight up with the point there, okay? So here's where we want to think. We are starting at 0, right? We go down 1, 2, 3. That's where this lines up with. So the z-axis is the only one that you can kind of draw and figure out, okay, where is it hitting or where is it lining up with, because those are straight tick marks, right? The rest of them are slanted. So you will have to kind of keep that in mind and kind of maybe extend out your lines a little bit if you need to. So we're going to say -3 there. All right, so those are a little bit more difficult because you don't have the box clearly lining up with the exact point on the coordinates, but we'll try that again, okay? And I think we'll get it figured out. So again, number 7, we look at the x-axis first. So with my x-axis, this one is kind of tricky, but we don't have an arrow going forwards or backwards, right? So take a look at the difference here. This one had an arrow going backwards. I don't have an arrow. I only have 2 arrows. I have an arrow kind of along the y-axis, and I have an arrow going up. So we're going to put a 0 there. So if you don't have an arrow, that means you're not moving that direction. So we're going to say 0. We have not moved forwards or back along the x-axis. Now I move to the y. So the y, this one is a little bit easier to see though, right? So I have 1, and it's positive, right? Positive there. So +1, and then now I can look up. I go up 1, 2, 3, 4 spaces, okay? So again, the z-axis is the only one where I really can count up and down because it perfectly goes in line with those straight tick marks there, okay? So that's how you read the arrows. So those can get a little bit more challenging, but if you extend out your, I don't know, I guess grid lines, you can say, you should be able to get them right. And some people are also good about just kind of memorizing the distance, right? This distance is always 1. This distance arrow is always 2. So some people like to look at that too when they're doing that. So you can kind of figure out, like just by looking at the length of the arrow, how many units you're going. Some people do it that way too. Okay, so you'll just try 8, 9, and 10 with those. And then now I'm gonna skip down to, I know I'm all over the place, but we're gonna skip down to 18 and 19 just because then the rest of these we're gonna have to keep flipping back and forth. So I'm just gonna do everything on this page. So we're gonna do 18 and 19 together, and then you're gonna do that whole back page, 20, 21, 22, 23. So you will just wanna circle that back page. These are not bad. These are really easy. Everyone really liked these last year. They look more complicated than what they are, okay? So let's look at my instructions. It says sketch each plane and write the equation of each trace, okay? So we want to take it back a little bit to geometry. A plane. A plane is a two-dimensional looking shape in that three-dimensional space, okay? So we're going to sketch the plane and we're going to write the equation of each trace. And so I'll talk about what a trace is in a second. So here's kind of, long story short, what we're doing. We are going to create 3 lines that kind of connect all of that draws this shape, okay? And so here's how we do that. It's kind of like the hide and seek method. We're wanting to find those intercepts. And so we can find my intercepts by zeroing out everything else, right? So we're basically graphing each X, Y, and Z intercept. And how do we get that? Well, I know that if I'm touching the x-axis, then that means I'm not moving along the y-axis. I'm not moving kind of to the right or to the left, and I'm not moving up or down, right? So we're at 0 there. So we can do that hide and seek method, but just for a 3-dimensional shape instead of that 2-dimensional shape. So I can say 4x equals 8. That would tell me where my x-intercept is, right? Because I'm zeroing out the other 2. I can also say 2y equals 8, and I can say negative 2z equals 8. So it's the same thing as if we were doing regular x and y intercepts for that linear, that 2-dimensional line. Now we're just finding 3 intercepts for my 3-dimensional shape here, okay? So we're going to say my x-intercept would be 2, the y-intercept would be 4, and the z-intercept would be negative 4. So that's kind of step 1. So all you're doing there is just identifying those intercepts, and then we can plot them. So we just need to make sure that we're going along the right space. So x equals 2. Remember, here's my x-axis. Coming towards you is positive. So this would be a dot right here at positive 2 coming towards me on the x-axis. My y-intercept would be 4, and so that one is a little bit easier to see. Going to the right would be the positive y, going to the left would be the negative y. And then z, that's up or down, so going down would be negative 4. So you're going to make 3 dots where your 3 intercepts are, and then I'm just going to create a straight line between each of those intercepts. So we see something like this, okay? And so then we can lightly shade in to show that this is a kind of a weird, it's a 2D shape, but in that 3-dimensional space, okay? So that is my plane, all right? But we want to take it one step further. We want to write the equation of each trace. So a trace is each of those lines connecting your intercepts to each other. So we can label this trace. So I'm going to highlight this green trace right here. That is connecting the x-axis and the z-axis, right? That's my x-intercept and my z-intercept. So we're going to call this xz. This one that I have in green here is connecting the x-axis to the y-axis, the x-intercept to the y-intercept. So we're going to call that one xy. And then we finally have this green line right here. That's connecting the z-intercept to the y-intercept. So we're going to call that yz. I just put them in alphabetical order. It's not wrong if you say zy. It's not wrong. I just always put them in alphabetical order, okay? So that's the label. We now want to write the equation. And so this is also very easy. So all we're doing here, so if I want to write the equation for my xy trace, again, each trace is the line connecting your intercepts together. So you have 3 traces. All you're doing is you're going to write 4x plus 2y equals 8. So you're basically keeping the terms of the intercepts that you're connecting, right? Because this is a straight line. This is a line, so it's gonna look like that standard form because it's just a line, right? It's not that whole 3-dimensional space. We're only connecting 2 dimensions. So we're gonna say 4x plus 2y equals 8. Okay, and then I can do the same thing. So for my xz trace, I would use the x and the z term and set it equal to 8. So we would say 4x minus 2z equals 8. And then for my yz trace, I would use the y term and the z term. So we'd say 2y minus 2z equals 8. Okay, so that would be what we want to do there. Okay. Now, technically, you can reduce this. I'm not going to make us reduce these, but next year, I think she might have you reduce them. Okay, so just a heads up. Like, so that way you know, okay, we know how to reduce equations, right? We can just divide. But I'm not going to make us. We already have a lot going on with this unit, so we're just going to stop there. So long story short, because I know most of us are just going to memorize this, and that's fine. All you're doing is taking and you're finding the intercepts, right? So you're setting each term equal to that constant at the end, plotting those points. You're connecting your lines. And then whatever two intercepts touch each other, you just use those two terms, right? So x, y, use your x and y term, set that equal to the number at the end. So it's nothing crazy. I think it's pretty easy, but it looks more complicated, okay? So let's try that one more time just so we get the idea of it here, and then we'll keep going. So I want to first find all my intercepts. So we have negative 9x equals 18, so x equals negative 2. Negative 6y equals 18, so y is negative 3. And negative 6z equals 18, so z equals negative 3. So I have my three intercepts, and I'm going to plot all three of them now. So x is negative 2. So here's my x-axis. Negative 2 means I'm going away from me, kind of against the page there. So negative 2 would be back 2 spaces. Negative 3 on the y-axis would be going to the left 3 spaces. And negative 3 on the z-axis would be going down. So now we want to think of y is left and right, x is forward and back, and z is up and down. So it is a little bit different to kind of think about that, but same thing. So all we're doing now is just connecting those points together, and then we can kind of lightly shade on the inside there. So here's that kind of two-dimensional looking shape in my three-dimensional plane, and now I can write the equation of each trace. So again, we want to take a look at what two dots are we connecting here. So here we have my y-axis to the z-axis. So this one is going to be yz. This one I have the z-axis to the x-axis. So we can call this xz. And this one that I have highlighted in green would be going from the x-axis to the y-axis. So this one would be xy. And then if I just write my equations, that's as easy as if I'm just writing xy first, I'm going to take the x term, which is negative 9x. I'm going to take the y term, which is negative 6y, and we're setting that equal to 18. That's it. So then we keep going. So then I'm going to do the same thing for yz. So yz, I'm going to take the y term, negative 6y, my z term, negative 6z, equals 18. And then the last one, xz, is my x term, which is negative 9x, my z term, negative 6z, equals 18. So that's it. So pretty easy. You don't have to worry about kind of moving anywhere. You're just plotting intercepts and then writing those equations, which could technically be reduced, but we don't have to. Okay, so you're going to finish up the backside. Once you get the hang of those go really, really fast. Everyone liked those last year. But now we're going to actually plot these points, which is where this can get kind of tough. So up till this point, it hasn't been too bad, I don't think. Plotting the points can get kind of tough. So if you notice, I have some extra pages at the end. I don't know where I put my pages. I'll have to find where did I put those. We're going to do 11, 12, and 13 together. So you're going to want to finish up the rest because I'm going to go off of this page in a second. So if at the end, you'll see that you have a whole bunch of like graph paper of my three-dimensional coordinates, okay? So you're going to do 14, 15, 16, 17. We're going to do 11, 12, 13 because I think we need 3 times of doing this. Okay, so let me figure out where I put my coordinates. Okay, yeah, right here. All right. Okay, so I think I gave you the exact amount to do. So each graph here is going to be one problem. So this is going to be problem 11. Problem 11 is 0, -3, 3. So that's what we are graphing, okay? And if you accidentally mess up, A, I would use pencil so you can just erase. But B, if you need more copies of these papers, let me know. I'd be happy to give you some. Okay, so again, this is X, comma Y, comma Z. So this grid paper is really, really helpful. And this is the exact paper that Mrs. Brundage will give you next year too. So I don't know if she made this or she found this, but it is very helpful. But we have to get used to kind of what I was saying earlier, that all of these tick marks are at a slant, besides the Z. The Z is the only one that the tick marks are kind of going straight. So if I'm starting with 0 on the x-axis, also, you will want a highlighter for this. Okay, sorry. I remember this is how we did this last year. You'll want a highlighter. If you don't have a highlighter, then I have some in the carts in the bottom drawer. So you'll want a highlighter for these. Because I think this is how she does it too. This is how I did it last year. So you'll want a highlighter. And then, yeah, I think that's it. So again, if you mess up, let me know. And I can give you more of these papers. Okay, so here's where we're at. So 0 on the X. That means we are not moving forwards or backwards. So we are good to just kind of keep your highlighter in the middle there. So we're good on the X. We don't have to do anything there. But now my Y. My Y is going -3. So we have to make sure that we're kind of doing this as a slant, right? So this is -1. Let me use a different color here. I'll do pink. This is -1. This is -2. This is -3. So we're going 3 dots to the left there, right? Because it's negative. So I would take your highlighter and I would highlight to -3, okay? And kind of stop there. So again, we're not moving forwards or backwards, but we are moving to -3, and we want to keep those at a slant. Now, it doesn't matter that it's at a slant right now because technically we didn't move forwards or backwards, but that will come in handy later, okay? So there's my Y, and now I move up 3 spaces on the Z-axis. The Z-axis is the only one where I really can count just directly 3 up. So here's where it's kind of tricky. If you want to, you can maybe kind of take your pencil and kind of lightly connect over, or you can just count up 3 dots, highlight 3 dots up. So 1, 2, 3 dots directly up. Because my Z-axis really is, I don't have to go diagonally. I do get to use those dots straight up and down. Okay? And so this is my answer. So you'll want to make a dot here, kind of on top of where you end, and there's your answer. All right? So you're more than welcome to kind of add in those grid lines if you need it, but most people are good using the highlighter, just kind of counting dots and moving around, okay? So that's my answer. You don't have to do anything else. So then let's go ahead and try number 12, where we're adding in, now we're doing X and Z, and then the 13 will be where we do all of them. So I'm trying to show you what it looks like if you have zeros in there, because those can kind of confuse people. So this one, we now have a 0 for Y, but we're at -4, 0, 3. Okay, so again, we are going to take my highlighter, kind of start back at the origin here, and -4 is along the x-axis here. And again, this one is kind of slanted. So we're going to go back 1, 2, 3, 4 spaces. So you can take your highlighter, highlight backwards 4 dots, okay? But again, those dots, that axis is kind of going slanted, okay? Now I'm not moving up or down. I'm not moving, or sorry, left or right. I'm not moving left or right because I have a 0 here for Y, okay? So we're good. We don't have to move along the Y-axis, all right? But I do now need to move up 3 spaces. That's my Z. And so we really are okay because each dot, we do get to count exactly 3 dots up. So I get to go up 1, 2, 3 dots. Here would be my answer, okay? Because remember, the Z-axis, I really am good. I don't have to worry about kind of going diagonally. The Z-axis is just exactly up or down. So from moving backwards, kind of away from me on the x-axis 4 spaces, I'm now moving up 3 spaces along the z-axis. There's my final dot. Some people, if you want to connect this over, you can, and kind of make that box outline like how we saw, you can. And maybe that'll also help you see that if you connect it along kind of parallel to your x-axis here, that it's also hitting at 3 on that z-axis, okay? So maybe kind of connecting in your lines will help you a little bit. And I know it's weird to look at first, but once we graph them, you will get used to how this coordinate system works, okay? So let's try 13. This is the last one where we're putting it all together now. We have all 3 movements, and we'll go from there, okay? All right, so we're at 2, 3, -1. So let's start with the 2, right? The 2 is my x-axis. That means I'm going to move forward, and so I'm also adding in just a little bit more kind of terminology here to help us with our directions. So we're going to take my highlighter, we're going to start in the middle, and I'm going to move forward 2 dots on the x-axis, right? What's important here is that, again, we're kind of going sideways, but that's okay. And so now I'm also going to move to the right 3, all right? So I just moved forwards 2, so this is where we're kind of going to the right 3, and this is where people can get confused. But we need to take a look at what's happening with my y-axis, and maybe just kind of sketching this out a little bit, we can see. So if we kind of follow my y-axis and how it's going at this slant, this is 1, 2, 3 spaces, right? Kind of notice how 3 spaces were over there. And so kind of pay attention to how these dots are lined up. We're kind of going along these dots. These dots are all spaces along the y, okay? This would be a space along the y, right? So if I ended here, right, I moved forward 2, you're now going to just go along parallel to the y-axis. We're going to go 1, 2, 3 spaces over, okay? So hopefully you can see that. So where we end, where we came forward 2, you have your highlighter there. Now we go parallel to that y-axis. We go 1, 2, 3 spaces to the right because it's that positive y, okay? So if you want to just remember, okay, forward 2, right 3. Then we have a -1. Now I go down 1. So the z-axis is, again, the only one we really can just go straight up and down. You don't really have to worry about kind of what angle you're going. We're going to go down 1. And so this is where I end. Okay, I'll use a pink color here. This is where I end. So again, the x is going forward. The y, we can say, is going to be going to the right. And then the z-axis there, we go down 1. So if you take your highlighter, you don't get lost as easy, okay? So forward 2, right 3, down 1, okay? So that's kind of how you can finish out the rest of them. So same thing, if you have 3 movements, just follow that in the right order. If you follow the right order, you're not going to mess it up, okay? So there's my point. All right, so you guys can try the rest there. I will say the graphing of the points, that is probably the hardest part, but I think we can do it. The other ones are not too bad. So if you want me to double check your points, you can, but I think last year I posted the key. I think I just posted the whole key. So it's at the point where please try your best and don't just take a look at the key, but I'm going to trust that you're actually trying these right because they will be on the test. But I think I just posted the whole key. Okay,